Work. All right, so thank you all for joining me today. My name is Cecil Phillip. I'm a cloud developer advocate at Microsoft. Essentially, that means that I'm a teacher. I do a lot of conferences. I speak to a lot of students, really around the goal of showing people how to use our tools and how to really get good with .NET and Azure and those types of things. Now, as you can see, we're going to talk about building web APIs in ASP.NET Core. So just a quick show of hands. How many of you are already familiar with ASP.NET Core? Been using it already for work? Oh, great, fantastic. So this is like this half of the room, not that half of the room. OK, gotcha. All right, so we're going to talk about building web APIs. This is not going to be like a 101 type talk, but essentially what I want to do is show you some of the new features and techniques that we have to just make that experience a little bit better for you. So let's talk about the current version that we have right now. So today we have ASP.NET Core 2.2. That's the current version that's out. I think 2.6 was released just the other day. And then currently we have previews of 3.0 that are. Now 3.0 is going to be a little bit different. 3.0 is only going to run on .NET Core 3 when that comes out. But some of the great things that you're going to see from that are performance benefits. The package sizes are a lot smaller. And so you're going to see a lot of good things if you decide to move over to 3. If you're using 2.1, 2.1 is our LTS version, our long-term support version. So that means that you're going to be able to use it for at least another 3 years or so. So the reason people like the LTS version is because there's not a lot of churn, there's not a lot of updates and movement and things of that nature. So if you just want like a stable train that you don't have to worry about too much, then that'll be the version for you to try out. All right, so I'm not going to talk about that too much. Let's kind of just dive into it and see what we're going to do. Now, I want to talk to you guys about conventions and analyzers. Let's start off with that. Now, if you've ever used .NET, ASP.NET MVC version 4, right, the one that runs on .NET Framework, you would know that MVC is very much of a convention-based type framework, right? So you know that when you do puts and posts and deletes and things of that nature, there's a certain expectation about where the information is going to come from, right? So for instance, if I have a complex type, for instance, like an object or a struct or anything like that, I expect it's going to come from the body, whether that's a JSON body, whether it's an XML body, whether it's whatever the case is. If I have a simple type, I know it's going to probably come from the query string, right? Like there's certain conventions that we just expect whenever we do these things, right? And so what I'm going to show you is how we can have some of these same conventions with ASP.NET Core, because if you might have known, like these things aren't exactly the same. So let's talk about Swagger for a little bit. Now, is anybody familiar with Swagger? I hope you guys are familiar with Swagger. This is like this half of the room and not this half of the room. OK, gotcha. OK. So with Swagger, essentially Swagger is just a way for us to document our APIs. So if you're in the business of providing APIs to the public, for instance, like if you sell APIs as a business or if you have internal customers that you service APIs to, an important thing for you to do is to provide them with documentation. Like what does it accept? What does it return? You know what I mean? How do I call it? What headers do I need? What does the security look like? Right? And the only way for you to do that is for you to provide them with some type of documentation. Now, usually developers aren't the best folks when it comes to actually writing documentation. Right? And then documentation gets stale. Right? And then you don't want to update it. And then now we have version mismatches and these types of things. So one of the good things that we get from using Swagger and OpenAPI is that we have these tools and frameworks that allow us to kind of plug into our framework, and it'll kind of inspect our code, it'll inspect our endpoints, and it'll just generate documentation for us, which is great, right? Because again, we don't like writing documentation. So as your code changes and your code updates, now it'll be able to generate some of this information for you. So now your customers, your internal customers, whoever, can now have really good documentation. And then on top of that, too, we'll get things like being able to generate clients and things of that nature. Now, I'll give you an example really quickly of what this looks like. Everybody can see that? Is that text big enough in the back for everyone in the back? So this is a pretty much basic example of what it looks like to create an action method, right? So we annotate it with HTTP delete. We have some code inside of here, and then we have some basic documentation at the top. Now, even though we can plug in Swagger into this, you can see we're not really providing a lot of information in terms of like what exactly this API does, right? Now, what we've enabled you to do is we can start to annotate these things with a little bit more information. So notice now I could say, well, this produces like a 201, and it produces like a 400 type. So now what that means is that when we plug in Swagger, when we plug in some of these API tool chains, that they can now look at these attributes and they can say, oh, okay, well, this is some additional information that your API provides. And now when we generate that documentation, that'll be inside of the documentation as well. Now, another thing that we've added, and I'm going to show you demos of these, but I just want to run through this really quickly so you all can see what I'm talking about. So another attribute that we added is the ApiController Attribute. So again, if you're used to MVC, Web API 2 and whatnot, Web API Controller used to be like a base type, and you used to have to inherit from API Controller. And then based on that, you get certain types of conventions and certain types of behaviors. And then when we got ASP.NET Core 2.1, instead of having to inherit from a controller, instead what we have is this attribute. And this attribute now is going to enforce some of those conventions that we were used to. So it'll do things like enforcing attribute routing. So that means that as soon as you put this, this API controller, this attribute on there, you can only use attribute routes inside of your APIs. So all of your API action methods have to have attribute routing specified in it. Right? It also applies binding conventions. Right? So before, if we didn't have this, I'd have to explicitly say exactly where all of my data is coming from. Right? I have to say it's coming from the body. I have to say it's coming from the query string. It's coming from the header. Right? And again, like as you write more and more APIs and as your code base gets bigger, this becomes a little tedious, right? Because now I have to keep adding these things over and over and over and over again, right? So for us, if we want to maintain and keep being convention-based, we can start using some of these types of things. That'll just make our lives a little bit easier. We also have automatic model validation, right? So what does that mean? So you ever have to do like a post or a put or anything like that, and then inside of your method, the first line of code you have is if model state is valid. And you have it at method after method after method after method, and you have to keep doing it all the time. Or then you create something maybe like an attribute filter or something like that, and then now inside of your filter, you have to write that code that'll say, hey, if model state valid, yes or no. Well, now that we have this API controller attribute, you don't have to write that code anymore. It'll just do it for you, right? Which is great, because again, it's just less code for us to write, less code for us to maintain. And then also we support something called problem details, right? So this is actually an RFC, an HTTP RFC, that specifies this is what errors should look like from APIs, right? And so again, this is just a public standard. I'll show you exactly what that looks like as well. And then we also have these API analyzers that we spoke about a little bit. And these analyzers are based on Roslyn. So if you're familiar with Roslyn, it's our open source compiler that essentially does C# and it allows us to do a lot of those interesting introspections that you might have gotten from like ReSharper or CodeRush or any of these other different types of tools you might have seen. Now, I think I've spoken enough for a little bit. Let me dive into Visual Studio Code. I'm going to show you an example of what some of this stuff looks like. All right, so I'm going to pop over here. So I am going to open a project that I have, right? And this is probably a little bit too small. Let me make this a little bit bigger. 22. Is that big enough for everybody in the back? This side, not that side. I don't understand what's going on. Okay, I'm just going to keep going. All right, so this is. I touched it. I'm sorry.
It's too small.
Yeah, apparently it is too small. Come back. Come back. Come back. Come back. Okay, all right, that's back. All right, I'm going to make it a little bit bigger. Try not to touch the cord. It's at 24 right now. Is that good? Yeah? All right, great. So this is pretty much a pretty basic API controller, right? So it's a CRUD controller, does put, post, create, update, delete, all that type of stuff. Now, I'm going to scroll down here and show you some of the things that it has, right? So I could get product by ID. Actually, I'm using JSON patch. Have any of y'all ever used JSON patch? No? So JSON patch is an interesting way for you to do updates, right? So essentially, I could send you a portion of a document, and then it'll only update that portion of the document, right? And I wouldn't have to pull in the entire thing for me to change it. And I'll show you an example of what that looks like, too. But that's just a more efficient way of us kind of doing like delta updates. So instead of replacing the whole thing, like I only replace a portion of the resource that I'm trying to update. But anyway, so this is a very basic API, right? Now, if I wanted to add Swagger support for it, I'll show you what my startup.cs file looks like. Now, essentially, I have a package that's inside of here. And from that package, I have the ability to just do add Swagger and add Swagger UI. Now, add Swagger is just going to add that definition document, right? So if I do /v1/swagger.json, it'll show me that JSON document that defines what my API is supposed to look like. So what the return types are, what the inputs are, what some of that basic information of that is. And then this Swagger UI is going to generate that, user interface that we could use to interact with this thing. So I'm going to debug this really quickly and show you guys really quick what this looks like without me adding any of that additional metadata information in it. So I'm running this in Visual Studio Code. Everything I'm showing you is going to run the same way, whether you're using VS or not. I'm going to go to /swagger. Right, so you see now it's generated this document for us, right? So I can open this document. I could execute commands and things of that nature. Right here at the top, zoom. Right, this here is the Swagger document that is actually created. Right, so if I click on this, this is the document that you'd pass to your client generation tools and anything like that to create clients that'll know how to talk to this API. Right. Now, this looks a little ugly, and it's probably a little bit hard to see. So what I want to do is, and I'm using Chrome, I'm going to go to the web store. Chrome web store. Because this is something that we do fairly randomly. And I'm actually going to install an extension. JSON viewer. Come on. There we go. Boom. Great. All right, great. So now this looks a little bit easier for me to look at and see, right? So now we can see what exactly it is that's here, right? So you can see that it'll have things like what the paths are, the verbs that I support, right? The tags that are inside of here. I notice it tells me that it produces JSON, right? So I could start to understand what exactly does this API is doing, okay? Now I'm going to go back to VS Code. Now, by default, our tools don't tell us a lot about how well this API is formatted, right? So one of the things that I want to do is I'm going to add that API controller attribute that I told you about earlier, right? So I'm going to add that attribute. And what you'll start to see now is, you'll notice here at the bottom, I'm starting to get these little squiggly lines underneath my methods. And essentially, it's telling me my API is not documented, right? It's not documented enough. I'm returning types and status codes and things like that, but I'm not actually providing that information so that I could have that included in my Swagger document, okay? So, and again, this works the same in Visual Studio. So what I'm going to do is I'm going to hit that little light bulb. And then notice now it's just added those properties for me. Again, much better than me writing this by hand because I'm lazy, right? And so what we could do now is we could go through method by method by method, and now we could just start clicking through and adding all of these properties, right? And now these things will just get included inside of our Swagger documents, right? Now it'll be able to tell us, well, these are the types that it actually returns. Right, now that's cool, but again, I'm lazy, right? So I don't want to keep adding this over and over and over again, all of these attributes on top of our methods. So one of the things that we can do, I'll come down. We have these things called API conventions, right? And what our API conventions can do is allow me to specify in general, when my API looks a certain way, these are the types that I expect it to return, right? And I'll show you what that looks like right now. Now, what I'm going to do is I'm going to add a reference here to API convention type, right? And this is going to be a type of default API conventions, right? I think I need to add that. Do I need to add that? Oh, sorry. This is a type, so I have to do type of. OK, great. Now, by me adding that attribute there, what it does is this yelling at me? Ah, got it. Thank you. That's why I like pair programming. Right, so now what this is going to do is going to allow us to, if I scroll down, you'll notice some of these squiggly lines are gone. I still have one there, but most of them are gone, right? Because now all of those attributes are just getting applied automatically because I said, hey, I'm going to use this convention, right? So now our Swagger document now is just going to, by default, include some of these things based on whether it's a put, post, delete, or whatever the case is. Now, let me show you what this document looks like so you can, this will probably make a lot more sense once you see it. Now, inside of here, what we're seeing is that essentially it's just doing like a match, right? So you say, I want to match the name by the prefix, right? And so this is a create method, and anything that looks like a create, by default, you're going to return a 201 and a 400, right? 201 is the 201 create. So if I have a create method, then, well, I'm going to expect you to return a 201 create if it's created successfully, right? Just like if you look at my deletes, right? I can have a 200, a 401, a 404 if I can't find the thing to delete, and, those types of things. So essentially, instead of us having to create all of these things and continuously add them on top of our methods, all we have to do is add that convention, right? And say, this is the convention I want to apply to all of my APIs. And now, again, this will apply, again, this is purely a documentation thing, right? So this is not going to make your code any slower. It's not going to add any overhead to what you're doing. This is purely from a documentation perspective. So when you're, yes, sir, question?
Is this something new in PO, or is it in 2?
This is in 2.1, so you could use it now. You don't have to wait for the beta. I'm going to show you the 3.0 stuff later.
Okay.
But this is in 2.1. You could use this today. No issues. All right. So again, this is not something that I personally wrote. This is just in the framework, and you could just use it. But also, if you wanted to, you could add your own conventions if you wanted to as well, right? All you have to do is follow the convention, right? And just follow what's inside of here. And you can create your own file. So I actually have one that I want to show you. That's mine, right? Mine's a lot shorter because, I didn't want to spend that much time. But as you can see, right, like, so I have one that if I have a method called get, and you notice my methods don't have to have any body inside of them. If I have a method called get, right, I want it to return a 404 if I try to provide you with something and you don't have it, or I want you to return a 200, and that 200 will have in the body whatever that thing happens to be, right? So just like I did with the other one, right, like I could replace this, and I could put mine here, right? So mine was product API conventions, right? And then now that'll apply to my API, right? But because I did it on the level of the assembly, it's going to apply to all the APIs that are inside of this assembly, right? Inside of this product. If you wanted to, you could apply it on the controller level. You can apply it on a class level. Again, I just put it here because it'll just work across everything, and that makes sense for me. Okay? But that's one of the ways that we could make that experience a little bit better whenever you generate your stuff. So what I'll do now is, let me put back what I had here before, and I'll debug this again really quickly, and I'll show you how our API looks a little bit different now that we've added some additional documentation to it. Okay, that's there. I'll just refresh this page. Right. Let's go to one of these ones. So I didn't show you this before, but as you can see now it shows me I return a 200. It shows me I return a 404. If I had more things in there, right, like it'll show me all those different status types that I return. So for, again, anybody that's consuming your API, they can really quickly just look at it and see, okay, well, this is what's happening inside of here, or this is what the expectation is. Or if, I don't know, if you wanted to reverse engineer somebody's API, for whatever reason, you have a contract here that'll show you, well, this is exactly what the behavior, that you're expecting should be. Yeah, that makes sense? Yeah? Yeah? Great. All right, cool. All right, so that is, that was that. Let's head back to the slides really quickly. Right, so that was API analyzers, right? And so to get that by default, I don't think it's included by default if you do, file new web API. You just have to add this package, Microsoft ASP.NET Core MVC analyzers, right? And then once you add that by a NuGet, you'll get that default convention, and then you'll be able to apply that to some of your different controllers and whatnot. Okay, let's talk about OData. Has anybody ever heard about OData? I'm going to look at this side of the room. So OData is not a new thing, but what we've been noticing lately is becoming more and more relevant for a lot of our customers. You might have heard about these things like Graph API, not Graph API, what is that thing called? GraphQL and like those types of things, right? Because we're seeing a lot more folks using mobile clients, smart clients, and these types of things, they want to have the ability to control the data that comes in and out of their APIs, right? So like you might have a model and your model has like 200 fields in it, and maybe I only want 2 of those. Or maybe I want like a built-in way for me to do querying and filtering and like some of these types of things. And that's not code I want to write all the time, right? So now, we had this in OData when, I don't know, man, like OData came out in what, 2007, 8, 9, something like that, a long time ago. But I think at the time, I think it was a little bit ahead of its time, because people then were like, I don't really need this. But now, because performance is such a big deal now, clients really want to be able to control the information that's going in and out of their APIs. So with OData now, we get essentially a collection of practices that, we get a set of conventions that we could use to have more efficient control over how we build our web APIs. Powerful querying features and all these types of things. And the cool thing about it is that because it's been around so long, it's been supported by tons of other vendors. Red Hat supports it, SAP supports it, all the IBM supports it in tons of their products and whatnot. So again, I don't want to talk about that too much, but let me show you an example of what it looks like to add OData to your project really quickly. So what I'm going to show you here, now OData controller looks very similar to a web API controller. Again, not a lot of difference there, right? So this is essentially the same controller, technically, that I created before. It does the same thing. It's just doing it with some OData conventions. So notice I could still use my API conventions and generate interesting Swagger documentation on it. I could still use my API controller thing to apply those conventions, right? And then the only real differences we're seeing here is that I'm adding this thing here, these attributes here that says this is an OData route, and that I want to enable querying. So essentially what will happen is that it's going to add like a layer on top of your controller that's going to do some additional querying and filtering for you. And if I come into the startup.cs file, I'll show you again what that looks like. Here inside of your use MVC, you just have to specify what are the things that I want my OData model to use, right? Now, in Web API 2, right, OData was very much tied to Entity Framework, which was a little bit of a problem for some folks because they're like, well, I don't want to use Entity Framework. I want to use a different database, or I want to use SQL connection. For whatever reason, you might want to do that, right? But now you have the ability to build your model based on whatever data type you want, right? So you're not tied to Entity Framework. You're not tied to any particular API. All you have to do is let us know what does this thing look like? Like, what's the shape of the information that you're returning? So in this case, I only have like one type, right? And that's just a products endpoint. And so now it's going to look at my product model, and it's going to say, OK, it's going to do whatever work it needs to do to generate an EDM model, and also allow us to do querying, filtering, and like all these types of things on it. Right? So let's run this again, just like we did with the other one, and I'll show you what this kind of looks like. Let's start debugging. Again, if you all have any questions or any OData jokes, let me know, and then we can talk about it. All right, so this is going to run, and while this is starting up, okay, now I'm going to use this tool called Postman. Is anybody not familiar with Postman and how Postman works? No, OK. All right, so Postman is a tool that I like to use for generating API requests and things like that. Right? So I'm going to show you an example of my OData request. So here, could not get response. That's not nice. Am I debugging on the right? Yeah. Really? OK, let's try this. What happened? Is this running? This is running. OK.
Usage HTTP.
Excuse me?
Try HTTP. Yeah, instead of HTTPS.
Oh.
5,000 instead of 5.
Yeah,
Huh.
it's a 5001.
Isn't that what it says?
No, you're on
HTTPS.
and
HTTP 5000.
5,000.
Okay.
That's weird.
What is happening here? That's not good. Start that. Let me rebuild this. That's weird. Okay. Rebuild it. Okay. Do I have something else running in there? No, I don't. Exit that. Kill that. Boom, boom, boom. Run task. Okay. And let's run this again. Right, okay. Localhost 5001. Okay. Boom, boom, boom. All right, so let's pretend that this is working, right? So this is what Oak data queries kind of look like, right? So if, for instance, if I had a query, right, and I wanted to, I didn't want to get all the properties of my product object, right? I could do something like this. I could do $select equals, and then now I could specify the actual properties of the thing that I wanted to get back. So I could do something like name, I could do ID, and I could do like SKU, right? So if my product model had like 20 properties on it, it would only return like those 3, right? Also, too, if I wanted to do something like paging, right, I could do something like $count equals to true, right? And now what that will do when I make that request is that will return to me a property that will let me know like how many of these things do I have inside of this database, right? Like it'll return to me the count. So then that means that I could start doing things like, let's say, give me the top 10 and skip, $skip, I don't know, 10, right? Whatever the case is. Right, so that'll take me to like the second page. You know what I mean? But usually, like, this is the type of stuff that we usually have to write ourselves, right? Like, I remember I used to write a lot of paging code, like, eventually I just put it into a library and just started copying it between different projects, right? Now, you don't have to do this anymore using OData. You can kind of just add it to, you can just add it into your query. Now, one of the reasons why I love OData specifically is because I don't necessarily have to change my API, right? Like, I can just add that enable querying attribute to it, and I don't have to worry about creating like a different model or a different way of interacting with my REST clients. So if you had to do something like GraphQL, I have no problem with GraphQL. I'm just picking on them. But if you had to do something like GraphQL, like your model of how you interact with your APIs is very different. Your clients are very different. If you have OData, I have my same semantics that I'm used to, and my investments of my existing APIs don't go away. All I have to do now is I just want to add like this additional functionality that allow me to do more efficient querying and give me a little bit more control over my APIs. And so that's one of the reasons why I love using OData when it works. So let's move on from that really quickly. Yes, sir.
So the OData provider in this case, so in your example, is that hooked up to an actual database, and do those queries go translate down to the database level? So for example, if you, in your example of paging, so I'm getting products. If I had like 10,000 products in my database, is it retrieving all 10,000 from the database and then applying the paging, or is it actually going to go down all the way to the database to do the skip and take?
Yeah, so depending on whatever your underlying model happens to be, then you can adapt it to do that, right? So in my case, it's not doing that, because then that code would look a little bit more complicated. But essentially, what I'm doing right now is I'm just saying, I'll show you what the model looks like, right? So I'm creating this model, right? And so the model is essentially letting the OData framework know what does this thing look like, right? And so now, what will happen, and what's good for your clients, is that instead of me returning the data and doing the filtering on the client, the filtering is happening on the server, right? And then also there's less information going over the wire.
Right, but So if this was wired up to SQL Server through Entity Framework, would that OData query actually translate to the SQL query to do the skip and dip?
So right now, this is not going on that way,
Right.
but it can.
Okay.
It can. So what you could do, I don't have an example of this, is that you could capture those OData parameters, right, and then you could just flow those down. I'm not flowing them down in this case, but that's something that you could do as well. But yeah, that's definitely something you could do. One other thing that I wanted to point out about the OData stuff that you'll notice here is that a question that we always get from people is, well, I don't want my clients to filter this way, or I don't want them to select this way, or whatever the case is. You can control what OData operators that your API supports. So notice here, like I said, I want to support select, order by, filter. If I just take them out, then they're not enabled, right? So if you don't want your folks finding out how many things are in the database, then you just take the counts out and you can't count them anymore, right? So again, like the more or less things that you put in here, that can really control like exactly what your API clients can do. Right. Let's move on from that and see if I can find a demo that works. Let's talk about gRPC. Right. So gRPC, so this is a .NET, great. This is a .NET Core 3 feature that we have. This is not in 2.1 or 2.2. And so we decided to add gRPC because we saw that there was a need for more, folks wanted like more contract-based API calls. So we think about REST and RESTful and API, web API type things. They're not very contract-based, they're more convention-based. So gRPC is a lot more aligned with things like WCF, right? And so we would have like a WSDL of some sort or some type of contract that'll say, this is what my methods look like, this is what my return and responses look like, and things of that nature. Unfortunately, so we're not bringing WCF over into .NET Core 3 or into .NET 5 whenever that comes out. But we did need, we did have a reason to have like some more contract-based things. So we're going to enable gRPC. And we were actually working with Google. gRPC comes from Google. It stands for Google, whatever RPC stands for. Procedure call. And so we've been working very closely with them to kind of make sure that they have really good support for .NET Core. One of the great things about it is that once you enable gRPC, you'll have the ability to not just talk to, very similar to REST, not just .NET clients, but you'll be able to talk to Python clients, to Go clients, and any of those types of things, but in a very memory efficient type way. Right? So we see gRPC used a lot more so for like internal services that are talking to each other. I think Google is the only company I know that has like a public gRPC API. But when we talk about, we're wanting to pass data back and forth between clients, usually that are on the same network or on the same, in the same cluster. And I really don't care too much about like those REST semantics, right? So what you'll notice about gRPC is that it's very much for point-to-point real-time communication. And then they also pass a very, it's a binary format. So again, it's very efficient. It doesn't take up a lot of bandwidth, and it goes very quickly back and forth over the wire. And that protocol that they use is called protocol buffers, right? So, and it's a serialization format, but it's also a way for us to specify that contract between the clients and the servers, right? Now, here's an example really quickly of what a protocol buffer contract might look like. So here, I can define my product service. And I'm going to have an RPC method called getProducts. And then you'll see I have the message that kicks off, that it accepts, and then the type that it returns. And then here at the bottom, you notice I'll have the properties of what my product looks like. Now, if you notice, like these are sequential, right? It goes 1, 2, 3, 4, 5 for a reason. Because gRPC is in a binary format, what it does is that when we specify the types and the positions, when it's serialized or when it's deserializing, essentially it's not looking at like JSON properties or anything like that. It's looking at the position to see, at this position, I'm expecting this data to be there, right? And so that's how it's able to create that very compact format for you to pass data back and forth. All right, now I'll show you an example of what that looks like too, really quickly. Right, so the interesting thing about gRPC is that I could create a profile. So this is what my profile looks like. like protocol buffers file look like. And again, just like the other two examples, I'm just creating the same API that I did before. Now I'm just creating it using gRPC, right? So I have these 4 methods that I've defined: get, add, delete, pretty much, my products. But then notice I also have to define my request messages too. The thing with gRPC, regardless of whether you're actually passing any information into the method or not, you have to still define a message type, right? So you notice here, my get products request has nothing inside of it, right? Like it's not passing any information, but I still have to define it, right? Because I need to have something to signal that this is the operation that I want to have run, right? And you'll notice that's associated here with this method here that's on this line. Now, you'll notice that, and I'll zoom in really quickly, you'll notice that I really have no other code inside of here, right? I just have that protocol buffer file. So what will happen is that I'll point my project file to that protocol buffer file, and then it'll just generate that code for me that'll run the client and the server, right? And I mean, obviously, you could override that too if you wanted to, but honestly, like that's all you really have to do, right? And so now it'll generate interfaces and base types that you could use to define, well, how exactly do I want to work with this service? Now, if I show you, so that's my protocol buffer file. If I'm going to open this service, and I'll show you, here's my implementation of that gRPC service. Right, so again, this service base class, this is all generated, so I actually don't have that. But if you look through here, all of these are just methods that I'm overriding based on side of that, right? So the contract, this product comes from that thing that I defined inside of my protocol buffer file. Get products requests, product message ID request, all that stuff came from that protocol buffer file, not something that I defined. And then now you just determine however you want to call it, right? So here I'm just using like Entity Framework in my case to do that. Now what the client side looks like, I'll show you that really quickly. The client side is very, very straightforward. So you get this type called a channel, right? And then you just new up your product service client. Product service client came again from that gRPC protocol buffer file. And then now I just need to call methods on it, right? But this is essentially all the code that's inside of my client. I don't have anything else going on inside of here. Now, the interesting thing with gRPC, I'm using a client's insecure communication that's inside of here. But if you wanted to, you could do things like, if you want to do OAuth flows with it, you could do OAuth flows with it. If you wanted to do TLS mutual certificate authentication, you could do that with it. Again, it's very flexible in terms of what whatever you use to authenticate it with. But essentially, that's all that there is to gRPC. At least that's all that we have time to talk about. Now, the last thing I want to talk to you about, and I'm going to do this really quickly, I want to show you some interesting things that you could do when it comes to microservices. So microservices has been a big deal. Everybody's been talking about microservices. And it's also been one of the main focuses for .NET Core 2.2 and now even 3.0. If you ever use Docker and Docker files and those types of things, you notice I think in 3.0 we're down to like a 47% reduction in the size of our Docker files. So again, consistently we just keep trying to make these things smaller and smaller and smaller. Because usually when people have Docker images, like you want to be able to have a lot of images and have a really dense infrastructure. And again, also too, we've been trying to increase our performance too. So not only are our images getting smaller, but our APIs are getting a lot faster as well. Now, one of the things that you might hear about too when you're talking about microservices is service discovery. Service discovery is something I'm personally a fan of. But with service discovery, we talk about 3 main things, right? We talk about where our service is located, are they up, right? Are they available? And what's the status of them? What's the health of these running services, right? So if I have 10 instances of a get product service, how do I know which one is healthy and which one is not? How do I know where is it located and where, what do I need to call it with? Yeah. One of the things that we added in 2.2 was the ability for us to have this health checks API, right? So the health checks API is interesting, and it's just a very similar package to some of the other things that we have. So you could add health checks to check for liveliness and readiness, right? Liveliness and readiness are 2 different things. Like liveliness and readiness are like saying, hey, I'm up, but I'm not ready to get requests. And then there's also, I'm just not up, and then not available at all, right? So differences between liveliness and readiness. But essentially, this allows us to be able to just check and see, hey, if I have 10 instances of a service that are running on my network, is it up or down? Pretty much is what it's saying. The good thing about this is I remember having to write this. I've written this like millions of times before in previous companies. So whenever they add things in the box that I don't have to write anymore, because again, I'm lazy, I just love it. I just love it. I think it's amazing. So let me show you quickly some examples of doing service discovery and doing some health checks in there. All right. So health checks. And this will be the last demo I do, and I'll let you guys go for lunch. I don't like to be the person that holds people up for lunch. All right. So this is my. All right. So to enable health checks, this is just a package that we need to add, right? And inside of that package, we get the extension method that says add health checks. So here inside of my configure services method, I'm adding a health check, and specifically, I'm adding one for my database, my DB context. So essentially what that'll do is I have my DB context attached to a certain database. When this spins up, essentially it's just going to ask me, can I talk to the database or not? Is your database up or down, or have I established that connection, right? And if it's not, then your health checks are going to fail, right? And then I have another one here that's essentially like a ping, and I'm pinging Google. Just for the demo, of course, I'm not really pinging Google for any reason in production. But if you had like some endpoint on your network or some API that you rely on, third-party service or anything like that, you might want to check and see if you could reach them, because maybe there's a network issue that you can't connect to. Maybe there's a firewall problem or something that you need to sort out, right? So what will happen is that your service will be deemed unhealthy unless all of these pass, right? So, and you can have other ones for these. There's packages for Redis and Cosmos DB and like tons of other services. You can kind of pick and choose which ones you want to use. There's actually I'll pop over to the browser really quickly. Have you ever heard about BeatPulse? Anybody know what BeatPulse is? No? Some of you? No? All right, so BeatPulse is essentially a open source project, BeatPulse, that will allow you, BeatPulse, to add some of these health checks to your projects. And they have tons of, is the internet not working? What's going on? Spinning. Great, there we go, okay. Right, so they have tons of these things, right? There's Redis, SQL Server, MongoDB, RabbitMQ, blah, 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 right? But you can wire up health checks for all of these things, right? So if any of these things are something that you use in your company, you could say, hey, my microservice depends on RabbitMQ for messaging, or it depends on MySQL or Kafka, right? Or it depends on identity server, right? And so even though your service might be up, one of these might be down. And so your application is in an unhealthy state, right? So it's not ready to be used, right? And then so we could just wire these up inside of here, right? For health checks. And then one other thing that I want to show you too before I switch over, and we also spoke a little bit about service discovery, and I'm rushing through this because we don't have a lot of time. There is a package that I like to use, SteelToe. Have you ever heard about SteelToe? Have you ever heard about Pivotal? Pivotal is a company, they do Pivotal Cloud Foundry, a lot of microservice work, more so on the Java side of the world. Well, so they have packages that allow us to use some of that work they've done for Java in .NET. So centralized configuration, service discoveries, and those types of things. And I'm going to show you how we could use the package that they have to do service discovery with a tool that we have called Console. And now I'm showing you all this because these all kind of tie together, right? So I'm going to show you how we do service discovery, and I'm going to show you how my service discovery tool is going to use those health checks to determine what's available and what's not available. Okay? Now, I have a task in here that's going to spin up a Docker container for me. And I'm going to spin up a thing that has, let's say 20, right? I'm going to spin up 20 instances of this service, right? So what you'll notice is that after a while, they'll start going green in a second. Green, 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 green. Some of them won't be green. And now if I come to localhost 8500, right? So now I've just spun up these services in maybe like 10 seconds or so, right? Now, these are all Docker containers that I just spun up. But you'll notice my node checks are green because, well, this is just saying the machine is up. They're on my machine. Hopefully my machine is up. So the machine is up, but my health checks are failing, right? But if I start to refresh them, hopefully over time, and actually I could even click on them and see what the problem is, right? Right, I can see this instance is failing for whatever the reason is, right? Now, I'm going to guess that I probably have an issue with my database because actually I'm not pointing to a database right now, right? But if I fix that check, I can come in here and you'll see these will start to go green. Now, what's interesting about this is that console is what I'm using for service discovery, and this is hitting my health checks. So now, if I wanted to make a request to console and say, hey, I need an instance of the product API, wherever it happens to be, I don't care which one you give me, just give me one that's healthy. I can make an API request to this thing, and it'll just give me back the status of these things, and now I can start to reason about it. So if I go to, right, I have a thing here in Postman that I do really quickly, right? So I'm just going to make this API call, right? I have a service called Products API, and I'm just going to say, give me the health of this service, right? And now it'll give me back this response from all of those instances that I have. And notice that it's telling me that the status is critical, right? So that means my health checks are failing, right? So now what I need to do is I need to figure out why is it exactly that my health checks are failing. And so I'd have to go in and fix them. And then after that, then it won't say critical anymore. It'll just say they're good, right? But this is good because usually when you have microservices, it's different from when you have like a service on a machine and I can log into that machine, I can SSH into that machine, I can RDP into that machine, and I could mess around and figure out what's going on. When you have like tons of instances of these things, you don't have the time to go through all of them and figure out what's going on, right? So now your health checks will definitely help you figure that out. And then also now you have tools like Console. If you're like in the world of Kubernetes, there's like Istio and Envoy and like tons of these other things that do very similar work. But essentially like your goal is to let me know what's available. Let me know what, like how many instances of that product API I have. Let me know where they are, and let me know what the status is, right? And that's what we get from health checks and service discovery. Okay, we're running low on time, so I'm just gonna speed through down to the end. I'll let you guys go and eat. So, all right, so we spoke about a lot of the features that we saw that we could do today, and also some things that are coming in 3.0. Some other things that we could expect to see is, identity server support. We have the new JSON APIs that are coming out, which should be interesting. So we're replacing JSON.NET with our own JSON APIs. That should be a lot more efficient. Allocate less memory, those types of things. And then also, so we're going to have endpoint routing, which is a different routing format. Apparently in programming, everybody likes to rewrite the router. Apparently that's like a big thing for people to do, for whatever reason. They do it a lot of the time in JavaScript, but now we're doing it in .NET. But we've rewritten the router to make it more efficient as well. And then again, better support for OpenSSL and TLS and those types of things. Now, if you want to grab links to the code, links to resources, anything like that, like you can head to theurlist.com. Shameless plug, me and my teammate built this, and this is completely serverless. So definitely, grab the code, check it out, take a look at it, and let me know what you think. I got 2 minutes for questions, if anybody has any questions. Anything you want to ask, anything you want to know about before we go? Yeah? No? Question in the back, sir?
So specifically with your Swagger documentation, I noticed that the function declaration was necessary in order to create a convention. But if you override it using a URL routing, is there anything you can use for like based off of like get calls, put calls for a convention rather than the name?
No.
No?
No. Sorry. Anybody else? No? Well, thank you all so much for coming. I appreciate it, and hope you enjoy the rest of your day.